Greetings, everyone, and thank you so much for joining us today. Today, I'm joined by my friend and colleague, Gino Sigismondi, and Gino is going to talk us through how to solve feedback problems in your sound system. A very important topic, a very hot topic, if I can be a little punny. But before we get into that, just a few items of housekeeping. First of all, this webinar is being recorded and will be available for on-demand viewing. It takes us a couple of days to edit it, but once it's available and ready, it will be available at shure.com/webinars. Once again, that website is shure.com/webinars. It's a great site to go to. You can see all of our upcoming sessions in addition to our past webinar archives. So there's a lot of good information there. So please visit shure.com/webinars. Second of all, as we go through the session today, if you have any questions, please feel free to type those into the question pane. If you do not see a question pane and you are logged in through the web app, look for a little circle with a question mark, I believe, and click on that to get to the questions. Or if you're using the GoToWebinar actual desktop app, look for a dark gray toolbox with an orange box with a white arrow on it and click on that orange box and you should see the access to the question panes there. Ask any questions you have, but please be patient. We will get to those at the end of the session. And then last of all, as you may be aware, we are not coming to you from our usual controlled environments. Most of the Shure associates are currently working from home, so Gino and I are broadcasting to you live from our home offices. And I just bring that up because I want to say if we run into any audio or technical issues, please just bear with us. We don't have our usual controlled audio and internet that we normally broadcast with. So be patient and bear with us if we run into any technical glitches. All right, I think that wraps up all the housekeeping. Let's learn all about how to solve some feedback. Take it away, Gino.
Okay, thanks, Cheryl. And hello to everyone. Or good morning, good afternoon, good evening, wherever it is you happen to be joining us from. It's a pleasure to get another chance to talk to you all about our different audio topics. We've been kind of on a tear lately with webinars. I was just did one last week on the microphone selection and placement for houses of worship. If you were on that one, you know that we alluded to this webinar because we mentioned I had a little section in that on how to solve your feedback problems. And this is a very I think relevant topic because it's something that everybody encounters, and it doesn't matter what sort of audio you deal with. If it involves loudspeakers and microphones in the same room for a sound system or PA system, it's likely you've encountered this before. As it said in the little blurb about the webinar that we had put out, every time you see a microphone used in a movie for some reason, I don't mean like the actual microphones used to record the speech in the movie, but whenever somebody's using a microphone on a stage to make an announcement or a speech or anything, it invariably the sound editor puts in a little squeal of feedback as someone approaches the microphone. That's like in the movies, they must feel like that's how you know that the microphone is working, is because it feeds back. But it doesn't have to be that way. So let's get into it here. Here's our agenda. We're going to talk a little bit about what feedback is. I think there's often some confusion about that. Is sometimes feedback becomes a generic sort of catch-all term that people use for any strange, unwanted noises they get in a sound system. But feedback is definitely a specific thing. We'll talk about how you can predict when feedback will occur. Believe it or not, it's not random. It's not totally random. There's actually some math you can use to figure out when feedback will occur. And then we'll get into the different techniques that are available for minimizing feedback. But let's just jump right to the punchline here. We're going to actually start with a little poll. I say spoiler alert here because, like I said, we're jumping to the punchline. I'm just going to tell you the answer to this question, but I kind of want to see where everybody is kind of at with this. So here's a poll. What is the cheapest and easiest way to avoid feedback? And there's some choices there. So go ahead and click your answers. I want to see what people are going to say here. Is it move the loudspeakers closer to the audience? Buy a microphone that won't cause feedback? Get an automatic feedback reducer destroyer? Keep the microphone as close to your mouth as possible? Or hire a good sound technician? Some answers are starting to roll in here. All right. Where are we at? 46% voted here, 48, 50% voted. Let's keep them rolling in here. Always the more the better on our poll. Let's see. So I don't know that anybody else can see it yet. I won't say what's in the lead because I don't want to bias anybody. We're at 73%. It's been open for almost a minute and a half. I'm going to let it go for another 10 seconds, and then we'll close the poll here. Right now we're at 75% voted. And we are going to close. All right. The poll is closed. Hopefully that means everybody can see it now. I see. It says it's sharing it. So, all right. So what do we got here? The winning answer here was 35% hire a good sound technician. Cheryl, it sounds like maybe I need to get back into that business. Maybe I could get some of these people to hire me and I can get rid of their feedback in their sound system.
So hire Gino. That's the answer.
Yeah, right. Yeah, right. And that assumes that I'm good at that. I don't know. I'm a little out of practice now. Well, that's nice to see that people have that much faith. And I suppose that is one way to do it. But keep in mind, we're looking for the cheapest way to avoid feedback. And I think that a good sound technician probably doesn't come cheaply, although I would expect that they would know the information we're talking about here. That is that. Number 2, keep the microphone as close to your mouth as possible. And number 3 was move the loudspeakers closer to the audience. And again, most of these things are viable ways to get feedback. But the number 2 answer, I mean, that's actually the one we were looking for here, right? Get the microphone as close to the sound source as possible. Maybe not this close, but I chose this image for a reason, which is, there's kind of a reason that a lot of singers and rock bands know that you should keep the microphone practically right on top of your lips. And because the closer you are to the microphone, the louder that the sound of your voice is going to be. The more you pull the mic further away, the more the sound engineer has to turn that microphone level up through the sound system. And the more they have to turn it up, the more likely it is to get feedback. So that's why we say it's actually the cheapest and easiest way to avoid feedback, because it doesn't cost you anything to keep the microphone close to your mouth. It's free gain before feedback, essentially. I'm really glad to see that buy a microphone that won't cause feedback finished last place there, because there is no such thing, right? And we would actually get this question to us in technical support sometimes, which people say, I'd like to buy a microphone that doesn't have feedback or doesn't cause feedback. Well, there really is no such thing. At any rate, let's move on here now so that we've got that. And again, so everything we're going to talk about is all of the other techniques. Again, keeping the mic close to your mouth is not the only technique for getting rid of feedback. It's just the cheapest, easiest way. But let's take a look at some of these other ones here. First of all, again, what is feedback? So feedback is actually, again, it's that sort of squealing or howling sound that you get depending on what frequency is feeding back, right? It's not buzz, it's not hum, it's not static, it's not any of these other noises. It's that definite squealing or howling sound that you get that is created when you speak or some sound gets picked up by a microphone and it goes through the rest of the sound system and comes back out the loudspeaker at a higher level, and the microphone picks up that same sound again, right? So it's a loop that requires all of these components to be active. Again, people tend to blame the microphone for feedback because that's the thing that you see that most people are aware of. But again, feedback is caused by this interaction of all of these components. So if you think about it, again, another way to minimize your feedback issues is to just avoid having the microphone pick up the sound that is coming out of the loudspeaker, right? Because that's where that loop has to occur. If the microphone hears itself essentially coming out of the loudspeaker again, that's where you get that feedback from. So again, feedback will occur when the sound level at the loudspeaker is greater than the sound level than the talker. So the microphone can actually be in front of the loudspeaker as long as the sound coming out of the loudspeaker is greater than the original source, right? So if I'm speaking and I'm speaking too quietly and I'm relying on the microphone and the loudspeaker to be heard, that means that the loudspeaker is often going to be louder than the sound of my voice, right? Which again is why having the microphone close to your mouth is desired, because the closer to the microphone your mouth is, the louder your voice is going to be, meaning that it'll be louder than the loudspeaker, and then you won't get that feedback loop. So that's when feedback occurs, right? What is gain before feedback? So the last time we did this webinar, we had originally titled it Maximizing Gain Before Feedback, but we decided to change the title because we realized a lot of that might not be a term that people are familiar with. But that's all gain before feedback really means, is that the sound at the mic, gain before feedback means how loud can I turn up my sound system before I'm going to get feedback. So when we talk about maximizing gain before feedback, we're talking about optimizing our sound system so that we can get the most possible level or gain before feedback starts to occur. So how do I improve it? Again, that's what we're going to get into next. Despite even the claims from Shure's own advertising back in the 1940s, again, just going to a cardioid pattern microphone isn't necessarily the number one way to improve your gain before feedback. Though we did have this goodbye feedback ad that was one of the original ads for the 55, which was a cardioid unidirectional pattern. Again, certainly helps over omnidirectional microphones, but it's not the main way. First thing we want to talk about is a concept called potential acoustic gain, which is that math I referred to that shows us how we can do this. But then we also want to look at directional components, again, cardioid mics and how that helps, and some more electronic solutions like EQ and feedback reducers. So potential acoustic gain, that's the first thing here. When we're looking at gain before feedback, right, and potential acoustic gain, again, which is how loud you can turn it up, what is the major factor? Again, these are all, things that people think might help maximize your gain before feedback. A bigger power amp, adding more equalization, choosing a different type of microphone. But as we already said earlier, again, the major factor in determining your gain before feedback is all distance. Not only just keeping the microphone close to your mouth, but also how close is the microphone to the loudspeaker? How close is the loudspeaker to the audience? These are all factors that play into gain before feedback. So how much gain should a sound system provide? Well, that's where we use this math formula to figure that out. Generally, your rule of thumb should be that if you consider that everyone in a given environment, whether it's a meeting room or a concert or a house of worship, whatever it happens to be, right? The idea is that your sound system should provide enough gain so that the person who is furthest away from the presenter or the talker or the performer, so that person can hear just as well as the person that's closest, right? So if I'm sitting right next to you, listening to you talk, right, I would want my sound system to be able to make sure that the person who's all the way at the other end of the room can hear you just as well as I can. That's sort of the principle that this formula works on. So first of all, you have to figure out what's called the needed acoustic gain, or NAG for short, right? Which is the minimal amount of gain that we need so that that furthest away person can hear as well as the closest person. And then potential acoustic gain looks at the distances of all these different components and figures out whether or not your sound system is going to work, whether or not it's going to be loud enough. And we used to have a bunch of slides that show us how to do this, but I'm actually just going to open up my web browser here because we actually have a nifty little tool on the Shure website that can show that. Cheryl, hopefully you can verify that we can see my web browser now instead of the slide.
Yes, we're seeing your web browser.
Excellent. Okay, so here you can see the link at the top, but it's also available on Shure.com under support, online and software tools, the PAG NAG calculator. Now, again, this shows a meeting room environment, but it doesn't really matter what your environment is. The math holds no matter what. You just have to plug in your distances. So in green, the green circles here represent all of the distances that we're concerned about here, which is D sub S, which is the distance between the microphone and the sound source that you're trying to pick up. D sub 1, which is the distance between the microphone and the closest loudspeaker. D sub 2, which is the distance between the furthest listener and their closest loudspeaker. D sub 3, which is our reference, the distance between the talker or the sound source and the closest listener. And then D sub 0, which is the distance between the talker or sound source and the furthest listener. Now, you don't have to remember all of this stuff because it's in a tool here on our website, but what you do need to know is what all those distances are so you can plug those in. One other factor that's not a distance but is important is the number of open microphones, because every time you double the number of open microphones in your sound system, you are 6 dB closer to the threshold where you're going to get feedback. So the more microphones that you're going to have turned on and active at the same time, the more likely you are to get feedback. So let's plug in some distance here. First of all, let's say, okay, how far away is the furthest listener from the talker? I'm just going to throw in some arbitrary numbers. 20 feet away. Great. Okay. How far away is the microphone from the loudspeaker? All right. So we look back up here. That loudspeaker, that's pretty close. That's right overhead. That's only about 4 feet away. The furthest listener from the loudspeaker. Now, luckily, this is a good system where we've got a loudspeaker pretty close to this listener. But what we're going to do is we're going to pretend that this is a typical sort of environment where there's microphones close to there's loudspeakers close to the microphones that are on a stage. Let's pretend this is a stage where you don't have loudspeakers distributed throughout the audience. So this particular person, he is probably a good 20 feet away from the actual loudspeaker itself. The talker to the nearest listener, that's our reference, right? That's these two people right here. So the closest audience member is only, say, like 3 feet away. The person is 1 foot from the microphone. We're assuming there's only one mic turned on. So let's put 1 in here. And the calculation automatically shows up in red, right? Our needed acoustic gain, we're saying that in order for this person who's 20 feet away to hear as well as this person that's only 3 feet away from the talker, we need 22.5 dB of gain. The current setup is only going to deliver 12 dB of gain. That essentially means as soon as we turn it on, we're going to get feedback. That's not a good thing, right? So what are the things we can do to try and get there? Well, we can try, like we said, and move the microphone closer to the talker. You can actually do half increments here. So I can go to, 0.5. And when I do that, I get 6 dB back, right? Like I said, any change, I was talking about the number of open microphones, right? Every time that doubles, you lose 6 dB. Same thing applies to distances. Whenever I have the distance between the microphone and my mouth, I gain 6 dB. Vice versa, every time I double the distance between my microphone and my mouth, I lose 6 dB. So by moving the microphone half the distance to my mouth, I picked up 6 dB. Unfortunately, we're still not there, right? I'm still actually about 4.5 or so dB shy of where I need to be. So what's another thing I could do? Well, I could try moving the loudspeaker closer to the talker or further away from the microphone. So let's see, if I actually move this person or this loudspeaker just a little bit closer, well, it actually has to be a lot bit closer. Remember, said you need to double distances. So let's actually not do that. Let's see, what other things can we do here? Well, let's see if we can get the microphone further away from the loudspeaker. So if we go 8 feet away, now we're in a good spot. Okay, so now we move the microphone closer to the talker by having the distance and further away from the microphone by having that distance, right? Now our potential acoustic gain is greater than the acoustic gain. However, it says here the system may still suffer from feedback, even though it's greater. Why is that? You do like to build in what we call a feedback stability margin of 6 dB. And why the reason you do that is you typically don't want to be running your sound system right on the edge of feedback. And if if the variables here between the potential and needed acoustic gain is less than 6 dB, you're skating right on that edge where you might just barely be getting into feedback. So we like to be a little bit greater than that. Let's look at some other things we can do.
Hey, Gino, quick question.
Again, sure.
Quick question from me. In your distance to the mic, in our view, it looks like you have it at 5 feet as opposed to 0.5 feet. Is that correct? Or is that just a weird view that we have?
Ooh, you might have caught something here. Hang on. Thank you.
No
Let's
worries.
try 0.5.
There we go.
Hey, that's better. Yeah. Okay. although the values here didn't change, so that might have actually been a glitch in the programming there, possibly, because we're still seeing potential acoustic gain where we want to. So thank you for pointing that out. It should be 0.5 or 6 inches. Let's call it that, right? So if this was a meeting room where we would have the ability to put multiple loudspeakers in the ceiling, you can see now this guy's much closer to the loudspeaker. He's maybe only, let's say, farthest listener to farthest loudspeaker, 5 feet, right? Now we're in very good shape. Everything is all green. And we could probably even put this microphone back to something that would be a more reasonable distance for a talker in a meeting room, whereas there's a foot away, right? So now we're in a much better situation. However, if we want to try and replicate this, that loudspeaker is not 8 feet away from that talker. It's probably only like 4 feet. So let's go back to 4 feet here. Oh, all right. Now we're kind of within that part where that margin where we might get feedback again. However, for those of you who do conference room design, you might be familiar with what's called a mix minus system or zoned loudspeakers, where the sound from the closest microphone here, the talker's mic, doesn't come out of their own loudspeaker, right? In a well-designed conference room, you wouldn't do that. You would zone it so that this microphone, this woman's microphone here, is actually only coming out of the loudspeaker that's far away. So now we can change this D sub 1 from 4 feet to maybe that's more like 10 feet away, right? And again, now we're in a green good spot here where the system will operate without feedback. Again, there's endless variations you should go through, and I encourage you to go play with this. It's nice that we have this on our website, because what we used to do in this presentation was just show people the equation and they would instantly tune out. Now you don't have to tune out. Now you just have to get your measuring tape out and figure out where your talkers are going to be sitting, where your listeners are going to be sitting, where the microphone is, where the loudspeakers are. Plug those numbers in, and you can predict whether or not you're going to get feedback in your sound system. I should also mention that this calculator assumes omnidirectional components, right? And as we're going to talk about in a minute here, using directional mics and directional loudspeakers helps. So it helps maximize your gain before feedback. So, but the point is, if you've done this math ahead of time, assuming omnidirectional components, and you know that you're not going to get feedback, it's only going to be that much better when you switch to directional components. But again, to summarize potential acoustic gain, again, to make any noticeable improvements, you either have to half or double your distances, right? So if the microphone is a foot away from your mouth, you're only going to get a benefit if you move it 6 inches away, or if it's 2 feet, go to 1 foot. If you go from 1 foot, from 12 inches to 10 inches, that's not going to make any difference really. So you always have to keep that in mind. Again, the easiest and cheapest way to increase your acoustic gain is to make sure that your microphone to sound source distance is as small as possible. And again, limiting the number of open mics will only improve the situation. Again, we're kind of beating a dead horse here a little bit, but just to sort of reinforce here again why you want to keep the microphone so close to your mouth or so close to the sound source is, again, because of something we call the inverse square law, which states that your voice level drops 6 dB with each doubling of distance. So you can see here, you know, if you're getting 74 dB, which is sort of a typical talker level at 1 foot, if I move the microphone 2 feet away, that's dropped to 68 dB. If I go 4 feet away, 62 dB, et cetera, right? So that there's the argument for keeping the microphone close to your mouth. Now, how do we keep the number of open microphones to a minimum? Of course, you could just turn on one microphone manually, which is a bit cumbersome. And this is where, for speech applications, something called an automatic mixer comes into play. An automatic microphone mixer is its primary function is to keep the number of open microphones as low as possible. That means if only one person is talking, only one microphone is turned on. If two people are talking, only two microphones turn on, et cetera, et cetera. But what it also does is it turns down the overall output of the mixer when it needs to turn on more microphones. So the amount of gain is always equal to that of one microphone. So if one microphone is active and a second person starts talking, the microphone very quickly turns on a second microphone and reduces the output of the mixer by 3 dB, which is what you need to do to compensate for now 2 mics being on. And then if we go to 4 mics, it's now 6 dB down, et cetera, et cetera. And that always keeps you within that feedback stability margin, always keeps the number of open factor equal to 1, no matter how many microphones the mixer has to turn on. There are some other audio benefits as well. It kind of just generally reduces the audio quality by not allowing as much sort of background noise and reverberation to be picked up by the system, and prevents comb filtering because it only allows one microphone to be active per sound source. But again, eliminating that number of open mics factor is kind of the thing we really care about. There are some additional secondary features to automatic mixers, which we don't really have time to go into today. But again, primarily we want to make sure that it keeps those unused microphones turned off or attenuated. The Shure SCM820 is an example of a digital IntelliMix automatic microphone mixer that works well in all of these applications. But I'll mention again, this is really for speech applications. And why is that? Well, first of all, we have to take a look at how automatic mixing works using the Shure IntelliMix algorithm as the example here, because, hey, it's a Shure webinar, so we're going to talk about our own automatic mixers. But the way our IntelliMix automatic mixing work is based off something that's called a automatic noise adaptive threshold. Essentially what that means is that the mixers on a per channel basis are able to listen to the ambient noise level in the room and automatically adjust their gating threshold per microphone. So for those of you who are familiar with noise gates that the sound technician operates, these types of auto mixers just set their threshold automatically. Again, the algorithm is able to determine what is speech and what is noise and gate the microphones off when it's only sensing noise. And then when someone speaks into the microphone, the speech level only needs to be 1 dB louder than the ambient noise level for the microphone mixer to gate that channel on. However, noise and musical program material can be much more similar in terms of their dynamic characteristics. And what that means is that musical information can confuse an automatic mixer. They really are designed only for speech only, which is very dynamic, right? Speech is kind of loud and soft, loud and off, and that's how the mixer is able to determine that it's speech. But we commonly get calls from people who run their choir mics through an automatic mixer, where the choirs can be very ambient in terms of you might hold a note for a long time, hold a chord for a long time. The automatic mixer thinks that's noise because it's not very dynamic and starts gating the channel off. But it might go off and then on and then off and then on. It gets confused by program material. So again, automatic mixers aren't a solution for musical applications, but in any speech application, typically, if there's ever going to be more than 2 microphones turned on at a time for speech, whether it's in a conference room, in a meeting room, or a house of worship, or presentation, whatever, panel discussion, automatic mixers are a definite lifesaver, and you certainly want to use those. Other ways to control feedback beyond automatic mixers and keeping NOM to 0 are to use directional components like cardioid pattern mics, equalizers, again, potential acoustic gain we already talked about. So again, when it comes to getting a microphone that is going to minimize the chances of feedback occurring, we have to think back to our original discussion of why feedback occurs. It occurs when the microphone picks up its own sound coming back out of a loudspeaker at a louder level. And that is why omnidirectional microphones tend to be more susceptible to feedback, because an omnidirectional microphone picks up sound from all around the microphone. So it doesn't matter which way you point the microphone, it's equally as likely to hear the sound coming out of that loudspeaker and cause feedback. So if we go to a cardioid pattern microphone, right to the right here, you can see a cardioid pattern mic has a null 180 degrees off from the front of the microphone. So now we can think about aiming the microphone towards the sound source and away from loudspeakers or other noise sources. But by aiming it away from the loudspeaker, now we are able to take advantage of these directional properties to help improve our gain before feedback situation. But I will say, again, the distance between the microphone and your mouth, or the talker's mouth, is still more important or more successful than just going to a cardioid pattern microphone. And where you see this most often is with headset microphones. A lot of the ear set microphones that you see presenters use, which is, again, the skinny wire that just sort of hooks over one ear and kind of comes down your cheek there. The reason those microphones can still be omnidirectional, yet you don't have feedback issues with them, is because that microphone is millimeters from your mouth. And because it's so close to your mouth, you can turn it up and even walk in front of the loudspeaker often because you're not asking for that much gain because it's so close to your mouth. You know, but if you take that omnidirectional microphone, let's just say you go to an omnidirectional lavalier microphone, right? Which is now the microphone is probably 6 to 8 inches from your mouth down, clipped to your tie or your lapel or something. It's much, much further away. You've lost all that additional gain before feedback, and you might need to go to a cardioid lavalier microphone to prevent that feedback. And that is why we're such big fans here of the earset headset microphones, and why we push those a lot is because, again, that's maximizing your gain before feedback by keeping the mic so close to your mouth. But that's not an option. You can't always use a headset mic. That's where you start thinking about going to cardioid or supercardioid pattern microphones to sort of maximize that gain before feedback situation. But again, the loudspeaker placement becomes really, really critical here, right? It's particularly if you're using on-stage monitors or floor loudspeakers. And here, now, when we talk about cardioid versus supercardioid, you need to be aware of where that null is. On last week's webinar, we talked about how the null of the microphone changes depending on where it is, if it's cardioid, supercardioid, or hypercardioid, right? Because it's not always 180 degrees off like it is cardioid. So if you're going to place a floor loudspeaker and you're using a supercardioid pattern microphone, now you need to move that loudspeaker to the null, which is 180 degrees off axis instead of 120 instead of 180, to make sure the loudspeaker is firing into that null there. And the Shure Beta 58, for example, is a supercardioid pattern microphone that I've heard sound engineers refer to as, quote, the feedback 58, meaning that they think it's more susceptible to feedback than an SM58 is. Actually, because it's a supercardioid pattern, which is tighter overall, you should get better gain before feedback with a supercardioid. Why does this happen? Because if you place your loudspeakers for an SM58, which is at 180 degrees, and you turn it up to some level, then you unplug your SM58 and plug your Beta 58 in with that supercardioid pattern. Now the null is facing right down into the loudspeaker. So you might get feedback there that you didn't get from your SM58. So it's not that a Beta 58 feeds back more than an SM58. It's that you have to keep that pattern in mind when you're placing your loudspeakers. In fact, we used to include, maybe we still do, I haven't looked in a while, but there used to be a little protractor type template thing that came with the mic that fit over the grill. So you put this little cardboard piece over the grill of the mic, and it had arrows showing you essentially what we're looking at here, which is where to place the loudspeakers when you use a supercardioid pattern microphone. So again, going to directional components can help, not as much as keeping the mic closer to your mouth, but just make sure you're placing your loudspeakers appropriately. Now, some directionality in your loudspeakers can also happen, but you need to be aware of the coverage pattern of your loudspeaker when placing it. And also keeping in mind that with directional loudspeakers, really what's directional is the high frequencies, the horn or the tweeter that is responsible for your higher frequencies. You can control the directionality, sort of where those sound waves go, versus low frequencies where you can't really control the pattern. Low frequencies just tend to be more omnidirectional, right? But for controlling high frequency feedback, you can do that. Also being aware that this happens more in the near field. When you get out into the far field that is further away from the loudspeaker and you're in kind of the more reverberant field of the room, you've lost that directionality. But just real quick, again, directional loudspeakers, right? If you've got this situation where the high frequencies are blasting right into the microphone, that's a recipe for feedback. But often just by placing it so that the high frequencies are going past or over the microphone. This is, again, why you like your loudspeakers for loud concerts at the front of the stage and not the back of the stage. You can kind of help that out. Or just angling it up, again, so that the high frequencies go past the microphone. This is all just about, again, being aware of the directional properties of your loudspeaker. So finally, we get to EQ. And for those of you who have experience mixing live sound, you might, particularly monitor mixing, you might know that the EQ is often the first thing that someone will go to try to help get rid of feedback. But we put it at the end here because really you should do all of those other things first, right? You should get the microphone close to the sound source, far away from the loudspeakers. Make sure that you're using directional mics. Make sure that you're keeping your directional loudspeakers aimed away from the microphones. Those are all the things you do first. And then if you still are having some feedback issues, now we can think about using EQ to get rid of it. And why do we use EQ to try and get rid of feedback? That is because the response of any given sound system in any given room is not linear. In other words, it's not flat, right? Certain frequencies are louder than other ones. And that's what we're trying to show you is this the measured frequency response of some random room. And you can see that at certain frequencies like 2000 hertz, 3500 hertz, maybe about 1.6 here, right? We've got these frequencies are louder in the room, or they're more pronounced in the sound system. And those are the frequencies that as you keep bringing the level of your microphones up are more likely to feedback first. So if you use equalization to reduce the sound system's output at these different frequencies and try to the extent that you can flatten out the frequency response of your sound system, that is going to minimize feedback. The most common tool for this tends to be the graphic equalizer, what is known as the 1/3 graphic equalizer, which is often a 31-band EQ. But the parametric equalizer is usually a better tool for getting rid of feedback than the graphic equalizer, because you can often adjust what's called the Q, or the width of the filter, so that you can kind of narrow it in on just a specific frequency that you're trying to get rid of. So what we're looking at here on this slide is showing the frequency response of the same three frequencies cut by the same amount using a 1/10 of an octave tight parametric filter versus a 1/3 octave graphic. And you can see here, again, with a 6 dB cut at 500 hertz, 12 dB at 1, and 6 dB at 2, with the 1/10 octave graphic, you've got three very narrow notches here. But the 1/3 octave graphic, which is very wide, it compounds and essentially sucks all the mid-range out of your sound system. So if you have to cut these frequencies with the graphic EQ, you've done much more damage to the overall sound of your loudspeaker. Now, the reason you see graphics used so much for feedback control is because they're quick and easy to use. You've got those 31 faders right in front of you. It's very easy to kind of go grab in an emergency situation, get rid of feedback. But try to use parametric EQ if you can first, if you need to use EQ to get rid of feedback. Finally, we come to automatic feedback reducers, right? Feedback reducers, feedback destroyers, feedback eliminators, whatever you want to call them. Essentially, all these things are automatic equalizers. So they have an algorithm that can go in and when feedback occurs, they can determine very quickly what frequency is feeding back. And then they just insert these very, very narrow notch filters to eliminate that, or to get rid of that particular frequency that happens to be occurring at any given time. But it's really critical to understand that these are not 100% foolproof devices. That is, if you put in a feedback reducer in your sound system, it doesn't mean you will never hear feedback ever again. There's some limitations, right? Number one, they're not predictive. That is, the feedback needs to occur first before it'll attempt to get rid of the feedback, right? There's no way for this device to know when feedback is going to occur. It just knows when it happens, and then it gets rid of it. Now, these devices can be very, very quick. And once a frequency does feedback, it'll get rid of it, and you shouldn't hear it again, but you might hear it at first. The speed of engagement, or how fast it's able to deploy a filter, is frequency dependent. It usually can figure out higher frequency feedback before lower frequency feedback. If multiple frequencies start to feedback simultaneously, that can present a problem, because now the algorithm has to work harder to figure out which frequencies are feeding back. So if you suddenly find yourself in an uncontrolled feedback situation, it may not help you. There's a limited number of filters. That means it's not just going to keep throwing filters out there as every time a new frequency starts feeding back. It might be 10 or 12, maybe 20 at the high end, but there is a limited number of filters. Also a limited depth. It can't keep infinitely reducing that frequency. It typically goes to a maximum of about 18 dB or so. And just like with automatic mixers, musical program material can fool a feedback eliminator. So if you are going to use one of these devices, it's often good to run it before sound check or during sound check, but then lock it so that it doesn't try to deploy frequencies that might be coming from the music that the device thinks is actually feedback. So they are a useful tool, but again, they're certainly not the be all end all. So here's our summary. Got to the end here. So if you don't have enough gain before feedback in your sound system, to reinforce that means I can't turn my sound system up loud enough before getting feedback. Here are the things you should try. Number one, I should have numbered this because it's an ordered list. You should always do things in this order. Number one, move the microphone closer to the talker. If you can't get that changed, then move the loudspeaker closer to the listener. Because remember, the closer the loudspeaker is to the listener, the less you need to turn it up. The less you need to turn it up, the less likely you are to get feedback. Keep the number of open microphones as small as possible. Use an automatic mixer if it's a speech application to keep that number of open mics as small as possible. Move the loudspeaker further from the microphone. And the reason this is further down the list is because that's not always practical, right? If the loudspeaker is fixed in place, you might not be able to change this. But if you can, it's a thing to try. Then think about using directional microphones. If you're using Omni mics that are handhelds or Omni gooseneck mics, maybe switch to something that is directional, or lavalier mics. Think about cardioid pattern lavalier mics, and also directional loudspeakers aimed appropriately. Once you've tried all of those things, now you can think about going in with an equalizer, and whatever frequencies are still giving you problems, eliminating those either by ear yourself or using an automatic feedback reducer. And that's it. The reason we say at the bottom there are no other solutions is because that's it. Sometimes we'll run through this list and people say, well, I'm still getting feedback. What else can I do? Well, there is nothing else. This is pretty much the list here, or slight variations within of how you can maximize your gain before feedback. Hopefully those tips will prove useful for people. Again, this is kind of a tried and true sort of science that's been at it for a while, and you really haven't seen anything else new come out because there really is nothing else you can do besides, get that mic in close and flatten the response of that loudspeaker system, and hopefully you'll be able to get there. So that's what I've got to say about it, which was a lot. Just a couple of resources that I can point you to besides the PAG calculator, which again is on the tools section of our website. We still have a document that I remember reading my first week at Shure in 1997, Understanding Sound System Design and Feedback Using UG Math. You can still find that in the document section of our website. You can search feedback under the FAQ, get some great stuff. There's an excellent chapter in the Handbook for Sound Engineers written by Chris Foreman called Sound System Design if you really want to nerd out about this stuff. Otherwise, don't forget you can go to the Shure Audio Institute page on our website to find a lot more great learning resources. And there's the contact info for product support. And back over to Cheryl for questions.
Great. All right. Lots of good info. Thanks, Gino. All right, so let's kick it off with the questions here. Question number 1. Does the direction of the speaker matter, i.e. the back of the speaker is 10 feet from the mic and the closest audience is 10 foot from the front of the speaker?
So yeah, this kind of gets into the directionality we talked about, right? And if what you're meaning is if the loudspeaker is facing away from the microphone, that will improve your gain before feedback, because the high frequencies, which are most directional, will be heading away from the microphone. So that absolutely can help. However, if it's a stage monitor, you don't have that option because it's just going to sound like a bunch of low frequency mush to the performer. So a stage monitor has to be spun around in that scenario.
Okay. Next question. And I think this one came in while you were showing the PAG calculator on Shure.com. I would like a live mix example that includes drum mics, a couple of 57s picking up guitars, and a Beta 58 for vocals. The drum mics include cymbal mics.
Yeah, great question. So that calculator doesn't necessarily allow you to go for that kind of configuration. And one of the reasons for that is if you think about your typical sort of rock concert, pop concert, type setting where you're putting multiple mics on drums and things like that, you have to keep those mics open all the time, right? Also, those mics are typically as close as you possibly can get them to the sound source, right? You're talking about a distance from the mic to the sound source that is less than 6 inches usually, right? So when you put all that in there, you don't necessarily want to use PAG-NAG for that. However, where you might want to use PAG-NAG is figuring out maybe your sound system gain for the vocal monitors, right? So that's an area where you can figure out what's the closest loudspeaker, how far is the microphone from the singer's mouth, that sort of thing. And that might at least let you know if your monitor system is going to provide enough gain before feedback for your singers. That's a way you might use that tool. But again, there isn't really a way to do that for like a completely mic'd, rock band in a concert environment.
Great. All right, next question. Are automatic mixers a function of the board or additional equipment?
So the answer is both. There are standalone mixers like the SCM820 I showed you, which is a hardware Shure mic mixer that is designed with the algorithms for automatic mixing. But there are plugins you can get for digital mixers, or some kind of come with that already. There's software versions, and like our P300 processor has automatic mixing built into it. There's software now that we have called IMX Room that has it built in there, IntelliMix Room. So it can exist either as a standalone hardware appliance or in software. Great.
Okay, next question. Why would you prefer an automatic mixer when we have gates available?
So for the reason that the automatic mixer doesn't require a human to do anything. That is, in an environment where the background noise level might be changing, the ambient noise level might be changing, the automatic mixer is going to adjust its threshold accordingly, right? If you were able to predict accurately what the background noise level is going to be, you certainly could set a noise gate yourself. But again, the automatic mixer is going to be able to do that, is going to be able to adapt much more quickly than a human ever could to that scenario.
Okay. Next question.
The robots are taking over. Sorry.
Next question. What is a good cardioid headset? Make and brand, please. I think we're probably only going to speak to one brand for obvious reasons.
Yeah, sorry about that. That's a hard question to answer because we also need to know the application, right? In other words, my answer would be different if we're talking about, a pastor presenting in a house of worship versus an aerobics instructor versus a singing drummer, right? So that gets complicated, right? Because if it was, and I'll just throw a few examples out there. Let's say you are doing like more of a theatrical presentation in a theater with headset mics. I would go for our TH53, which is part of the new Twinplex lineup, which is an omnidirectional microphone. But again, in a theater application like that, it can work. The microphone's really close to your mouth. It's consistent. It sounds good. But I wouldn't use an omnidirectional microphone headset on a drummer, because now that's an additional drum mic. So I would want to go with something that is super or hyper cardioid with a really tight pattern, so that you're not picking up any of that other stuff. So something like maybe our Beta 54 headset mic would be good for that. And if it's a fitness instructor, that's different yet again, because now I need something that is going to be sweat proof. So the answer really depends.
Great. Quick side note, when you were talking about the cards with the Beta 58 for monitor placement, someone chimed in that we do still include them. So glad
good
to know.
Good to know.
All right.
That's great. That's such a throwback. It's so old school. I love it.
All right. So this next one I think we kind of already touched on, but I'll just ask it to maybe reiterate it. What effect is stage monitor setup on feedback, i.e. singer's voice in the monitor?
Yeah. Right. Well, yeah, hopefully maybe that question came in before we addressed it. But yeah, as you can see, it's almost a worst case scenario in terms of gain before feedback, because as we said, feedback occurs when the sound coming out of the loudspeaker is louder at the microphone than the original sound source. And if you think about it, you're trying to make it loud enough at the singer's ear so that they can hear themselves over a drum kit and guitar players and all that other stuff, right? When their ear is really close to the microphone. So it's the worst possible scenario. Yet it can be done, right? Supercardioid or hypercardioid pattern mics with good flat response loudspeakers and maybe a monitor sound engineer that knows what they're doing. You can make it happen. But that's also a great case for in-ear monitors, which
just
is
going to
another
say that.
webinar we could do, right? When you have the loudspeakers sealed inside of your ear canal now, you've broken the feedback loop and you don't have to worry about it. That's one of the main benefits of in-ear monitors is plenty of volume without having to worry about feedback. I'll also throw in there at this point, because I usually like to mention it during this webinar and I forgot, right, is you sometimes encounter a scenario, particularly in houses of worship, where there's a pastor who wants a monitor for their own voice that is being picked up by a sensitive gooseneck microphone. That is not going to work. That is an absolute recipe for disaster, because the gooseneck lectern mic is typically a foot from your mouth. And if you try to crank that level up through a loudspeaker that is right next to the podium, it's just not going to work. Give the pastor an in-ear monitor if they really need to monitor themselves that loud. Also, choir mics and monitors, do not do that. Where the microphones are hung several feet from the choir. Several microphones hung several feet from the choir. If you try to reinforce that into a monitor, it's a recipe for feedback. You can certainly put the band in the monitors so that the choir can hear the band. You can put, maybe the worship leader in there so they can hear that, but a choir cannot monitor themselves through stage monitors. Does not work.
Great. All right, next question. Can you recommend a way to EQ for someone who doesn't have the funds for a good real-time analyzer?
Well, I would say maybe first of all, think about getting an automatic feedback reducer that can automatically determine. It's essentially an analyzer in and of itself that figures out where the feedback is. However, if that's not in your budget, you have to start doing some ear training, I guess. Feedback frequencies, monitor engineers that are good at getting rid of feedback with an EQ are able to do that because they can recognize what frequencies are feeding back and then reduce those accordingly on the equalizer. If you don't have that ear yet, you can just start by, when there's few people in the room, you don't want to do this in front of an audience, but during a sound check or whatever, you go to the EQ and you start boosting frequencies that you think might be feeding back. And once you boost it, it'll feed back even more. And once it takes off, that's the one, bring it down a little bit and see if that helps. And it's going to take some experimentation and some learning, but that's essentially how you do it. And I know there are a number of modules and courses you can find online for ear training specifically for equalization that will help with that.
Okay. Next question. Could you talk a little bit about how potentially getting the correct preamp level first might affect feedback?
So setting your preamp gain on your mixer doesn't really have much impact on gain before feedback. However, it does improve your overall audio, your overall gain through your sound system, right? So in other words, if your gain is set too low on your mixer, your preamp gain, you're going to struggle then to push your faders and push your amplifier levels up louder so that the talker can be heard, right? Which is more likely to cause feedback. So setting your preamp gain high enough is sort of the equivalent of also getting your microphone close to your mouth. However, and this is where setting preamp gain maybe isn't quite as relevant, if the talker is too far from the microphone and you try to make up for that by boosting your preamp gain, you're still going to have feedback issues. So again, setting preamp gain is great for as a best practice for gain structure in general, but it can't necessarily compensate for a microphone just being too far away.
Okay. Next question. In live self-mixing applications, all mics are open and the distance when no one is singing is equal to the distance to the speaker. Can you comment about this situation?
Sure, it's not a good situation, but it's a situation that a lot of us find us in, right? So, this comes down to mic technique, right? Keep teaching the performers singers, I'm thinking is what we're talking about specifically, to be as close to the microphone as possible. And if you are mixing yourself, if you do have mics that people aren't using, for a certain song or a certain stretch of the set, definitely turn those off. I know it's not practical to do that in the middle of a song, but if you can at least get to the level of turning off the mics when they're not being used or turning them down in between songs or sets, by all means do that. And again, just pay critical attention to using mics, the most directional mics that you can. good loudspeakers, and like we just talked about, learning to use your ear to tune the sound system during sound check to use EQ to minimize that feedback. Because again, you can't really do it while you're performing. So definitely spend as much time as you can in advance trying to reduce those feedback frequencies.
Great. All right. Next question. Can you talk about appropriate use of high-pass filters?
Well, a high-pass filter is a good thing to use in terms of kind of clarity of sound, I guess. So, and for those who don't know, a high-pass filter is essentially an EQ that you can put in that lets high frequencies pass, but not low frequencies. So a low cut filter kind of does the same thing as a high pass filter, 6 of one, half dozen of the other, right? And if you think about, most high pass filters, they can often be adjustable. If they're not, they tend to be around somewhere between 100 and 200 hertz, right? And most sounds, most instruments, most humans can't create many sounds that are useful below that frequency. So it's always good to turn them on to get rid of unwanted noise like vibration noise, handling noise, stand noise, low frequency instruments like bass drum and bass guitar that you don't want being picked up by the mics. A high pass filter can be helpful for that. Doesn't really do much for gain before feedback, though, unless you happen to be getting a lot of really low rumbling feedback, which is less likely to occur. You don't really have to worry about those. So I would, again, use them for tonal characteristics, for cleaning up your low frequencies, but not necessarily for feedback reduction.
Okay. We have a follow-up to the question about the self-miking or self-mixing application. This person said, I'm thinking mic switches on the mics for self-miking situations might help.
Sure. Yeah, that's a great way to, make sure your unused mics are turned off, is one that has a switch on it. Those are sometimes difficult to find. I'd say most pro mics don't have switches on them, and that's often because they don't want the talent to accidentally turn off a microphone. The sound engineer would prefer to have complete control over that, but you're absolutely right. If you don't have a sound engineer and you're mixing yourself, by all means, get a mic with a switch on it. Or better yet, get a stomp box that can do that. I think it's Proco and some other companies, Whirlwind probably, they make a little stomp box that you plug in the line in between the mic and the mixer that goes at your feet, and then you can just put your foot on it when you need to mute the microphone. So that's a great tool for something like that.
Also, a lot of wireless microphones have an on-off switch. So that's another option. So awesome. Do we have a resource that lists the polar pattern per Shure product?
Let's see.
I can answer that, actually. If you go to our website at shure.com and under products, you select microphones, you can actually filter lists that way. So you could filter, I believe there is a polar pattern filter available on shure.com when you search mics, so that you can pull it up by polar pattern.
Well, there you go. Because I was struggling to think if there is a spreadsheet or a PDF document that shows them all, but that would be a big document. So if you actually want to see the patterns, like we kind of looked at some example polar patterns here, those are in all of the user guides. So once you've picked the model that you want to look at, it's worth looking at the user guide, particularly because not all patterns are the same. I mean, those patterns that we looked at for a cardioid and supercardioid pattern are typical representations at one frequency, but microphones is one of the things that differentiates microphones, not just different Shure mics, but mics amongst different manufacturers, is the consistency of the polar pattern, meaning that a supercardioid pattern microphone might look one way at 1 kilohertz, but different at 500 hertz and different yet again at 4,000 hertz, right? In other words, the patterns get more difficult to control at lower frequencies. But one of the things that makes a mic a good mic, right, try and say that without being subjective, is how consistent is it polar pattern, right? The closer a mic adheres to that sort of what you would consider a golden sort of textbook supercardioid, the more it holds to that pattern or that shape at different frequencies, determines how quote unquote good of a microphone it is, right? A bad supercardioid mic would be one that starts to get omnidirectional very quickly at frequencies that aren't even really that low. So you want to look into the user guide. If you're really kind of nerding out and getting scientific about it, that's where you would find those polar patterns.
All right. And I just confirmed I went to Shure.com, and if you go under products to microphones and click on the more filter options, one of those filter options is bipolar pattern. So you can divide them up that way too. Okay, next question. Can we use polarity and delay to increase gain before feedback?
Well, depends on who you ask. So let's take them separately. The polarity discussion, this kind of harkens back to the old Grateful Dead wall of sound. For those of you who have ever seen those somewhat famous photos of the Grateful Dead's touring rig from the 70s, where the speakers were actually behind the microphones. And what they would do is, if you looked even more closely, you would see that everybody, all the vocal mics particularly, were double mic'd. Everybody had two mics. And what you would then do is invert the polarity of one microphone that is taped essentially right next to the other microphone. And when the sound coming out of the loudspeaker gets picked up by both microphones that are right next to each other, but the polarity is inverted on one at the mixer, it should cancel out the sound being picked up from the loudspeakers, thereby eliminating feedback. And I wasn't alive then to go to these shows, but from what I understand is that actually worked fairly well. But that requires double miking everything and inverting the polarity of every microphone. So if it was something that was really a good technique, a good practical technique, I think you would see it a lot more often than you do. So the answer is kind of yeah, maybe. Delay is sort of meant to do a similar sort of thing, whereas you delay the signal enough to put it 180 degrees out of phase or an opposite polarity, you would get the same effect. But again, difficult to implement, not really practical. So an esoteric method at best, I would say.
All right. So we've got a follow-up to that question about the patterns. And actually, this person was looking for frequency patterns for each microphone, not polar patterns. And that is unfortunately something that you would have to pull up in the user guide. But all of the user guides for our mics are available on Shure.com. You just need to go to the mic product page, scroll down to documents, and you'll be able to download the user guide, which will have the frequency pattern response.
We just have too many microphones to have one document with all of them in there. It'd be a long list.
That is the truth. All right, next question. Thanks for mentioning the SEM820 auto mixer and auto feedback notch filters. These devices have reduced my stress exponentially. I have purchased a few Shure DFR22 automatic feedback filters, but the RS-232 connection is problematic and essentially obsolete. Would Shure consider retrofitting these units to connect to a PC with a USB connection instead of an RS-232 connection?
We would certainly consider it. Whether or not we're actually going to do it, I can't say. I'm not in product management, so I probably shouldn't comment on those things. But I will certainly pass that along. Being in technical support, I'm well aware of what you are experiencing with that. I will note, and again, that thing is a pretty old piece of hardware. It's more than 10 years old at this point, but we still continue to sell them because they're really good at what they do. And as a feedback reducer, you don't need to worry about that RS-232 port. You don't even need to hook a computer up to it. It actually has 3 selectable onboard presets that work for a variety of situations. So out of the box, you can plug it in and use it for that. The reason you would connect to it with a computer is to run the DFR22 software, which makes it more of a fully featured DSP with EQ and dynamics processing and some other things, which are cool, don't get me wrong. And it'd be nice to be able to make it easier for people to run that software and take advantage of those. But if you're purely looking at it as a feedback reducer, at least know that you don't have to worry about connecting a computer to it. But yes, great question and great comments, and I'll be sure to share that out.
Great. All right. Next question. My issue is that I have 4 handheld microphones, but when they are using all 4, they get a lot of feedback or strange sound in one of them.
In one of them. If it is indeed feedback and it's only occurring with one microphone, a guess, and this is purely just a guess because I know nothing else about the setup, is that the one that's closest to the loudspeakers? Because remember, that's one of the major factors is how close the mics are to the loudspeaker, and maybe it's just that one microphone is closer than the other ones. Also, are they all the same type of microphone? Because other different types of mics, depending on the pattern, might be more susceptible to that too. So there's a lot of factors that could go into that, if indeed it even is feedback. Like you said, you mentioned strange noises, so maybe it's not even feedback. I'm not sure, but feel free to ping us offline at support. Maybe we can try and dig into that a little deeper and see if we can figure out what's going on there.
Fantastic. All right, next question. If an engineer has explored all the feedback reduction points on this list, would another option be to ask the speaker if he or she can speak a little louder? Might improve the source level into the mic.
Absolutely. Yes. I mean, not only being close to the mic is the same thing as being louder, right? So if for whatever reason they can't practically get any closer to the microphone for whatever reason, then yes, being louder will absolutely help. And that's why, again, as a former practicing sound engineer, singers that don't sing loud used to drive me insane because they would want more monitor level. And when I would turn it up, it would start to feedback. I say, I can't give you any more. And in the back of my mind, I'm thinking, like, how about you just sing a little bit louder, and then I don't have to turn it up so loud. Sound systems should never be thought of as a substitute for poor mic technique, or I'll just say poor performance technique as well, right? That goes for theater as well. If you think about the small box theaters that don't even use microphones, you expect the performers to present, to be loud, right? And I always tell people, and when consulting in that environment, just because I'm putting a microphone on you doesn't mean don't project anymore. Pretend there is no microphone. Project like you normally would, and we'll let the microphone supplement that. So sorry for the tirade, but yes, be louder. Always be as loud as necessary for the situation.
Sing out, Louise, if I have any musical theater geeks in the audience today. All right. What is the best iPhone app for detecting the feedback frequency while a church service is going on?
I don't know. And I'm only just showing my ignorance here, and that I haven't actually gone down that path. I'm sure that there are iPhone apps that are essentially like a frequency analyzer or a real-time analyzer. Again, maybe there's if there's anybody else on the call here that has experience with those that would like to type one in for us, that would be great to know. I just haven't used them myself, but a real-time analyzer app is what you would be looking for that displays frequencies.
Great. Next question. Does 6 dB avoid the ringing before feedback?
Well, keep in mind 6 dB. I mean, that's just a ratio. It's a number, right? And when I was talking about 6 dB, what I meant is, maybe this is referring to my saying that you want, that you can see changes in 6 dB increments, right? The reason for that is because that's a noticeable change, right? If you're going to go about changing anything, any distances of components, locations to change the distance in your sound system, if what you're changing doesn't make at least a 6 dB difference, then it's not worth it. So I think that might be more along the lines of what you were asking, right? So, if by moving loudspeakers is a good example of this, right? Because can be a hard thing to do, right? If I'm going to move a loudspeaker, I want to make sure that I'm getting at least 6 dB difference. Otherwise, what's the point in moving it, right? And with a loudspeaker, you have to have the distance, right? If the loudspeaker is 10 feet away from the audience, I need to move it to 5 feet to realize that 6 dB distance. But if I'm going to go through the trouble of moving it, I might as well move it that much to get a 6 dB difference. Hopefully that answered the question.
I have a couple of follow-ups to that app question. Someone suggested an app called Audio Tools. But somebody else mentioned that the phone real-time analyzers need you to input your speaker response curve, and that's their weakness. So just a few comments on that front.
Yeah, or the other thing too, you might need, you definitely are going to need a good external microphone for that, because the microphone on the iPhones themselves are not great, right? So you will, and I know there are USB measurement mics out there that you can get, so you would certainly want to look for something like that too.
Great. Got a couple more suggestions. The Audio Tools by Studio 6, iPhone app called Acoustic Tools. So there we go. Just a couple of suggestions. Okay. Next one. When I have feedback during a live show with a cardioid microphone on stage, which frequencies should I cancel firstly?
Well, that actually has nothing to do with the fact that it's a cardioid mic, but everything to do with which specific microphone it happens to be. So all cardioid microphones have different frequency responses. So there really isn't going to be a universal answer to that. But using the SM58 as an example, its presence peak, which is where it's more sensitive, tends to start somewhere around 2K and go up to 5K. And not necessarily all of those frequencies in that range are going to be feeding back, but based on the loudspeaker response and what's going on in the room, it's likely that a frequency somewhere in that range might feed back first. And again, you wouldn't want to eliminate all frequencies in that range because then you've flattened out the presence peak and now it doesn't sound like an SM58 anymore, which is kind of something that people tend to like. So, but again, if you want to look at the frequency response chart of the mic and see where those areas of increased sensitivity are, and that would let you know for that particular microphone where you might need to start notching things out.
Okay. Next question. Should you set up noise gates on all mics?
Well, in terms of our discussion of trying to minimize feedback, I don't know that would necessarily help, right? A noise gate does, again, and this is probably used more in like a musical concert reinforcement environment. They can help clean up your mix by not letting, unwanted sounds through the sound system, but they're not really going to help with gain before feedback because they do nothing. Remember, one of the main things an automatic mixer does, in addition to only turning on mics when they need to be, is as it turns on more mics, it automatically reduces the mixer output so that you don't get into a feedback scenario. But when you're using noise gates, those are working independently and they wouldn't do anything to help your number of open mics factor.
Okay. Next question. Can you split microphones via a snake from overhead microphones to feed backstage monitors using an SCM 820 and DFR 22?
Possibly. I mean, the SCM 820 has two outputs on it. So an A output and a B output. So if you connect your mics to that mixer, you could certainly send, the A outputs to the stage and the B output to the backstage. Don't know that you would necessarily need the DFR 22, especially if you're going backstage, because if the mics are in another room, another location, they're actually probably not likely to cause feedback. So that you maybe don't even need an 820 for that, but you could certainly use it for that.
Okay. All right. We still have quite a few questions, but we've kind of gone over time, so I don't think we're going to get to all of these. So I just want to make a note really quick. If we didn't get to your question, or if you have a question that pops up, you can always reach out to Gino's team of applications engineers by going to shure.com/contact, and you can fill out that form there and open up a ticket with them, and they can answer most questions across many audio types. It's a great team of guys and gals, so I highly recommend.
And actually, if you go to the shure.com/support, you can search our FAQ there.
Perfect. So shure.com/support for FAQ search and shure.com/contact to open up a ticket. All right. I think we'll just wrap it up with one last question. What is the best polar pattern to avoid wind noise?
Oh, that's easy. Omnidirectional.
There you go. All right.
However, I'll just put a caveat on that, right? But given our discussion, right, we know that omnidirectional mics can be the most susceptible to feedback. So, that's why in audio, the answer to so many questions is it depends, right? So that was a very specific question that has a very simple and specific answer, but that doesn't necessarily mean you always want to use omnidirectional microphones in an outdoor application because you might have feedback issues. It might be really noisy and it's going to pick up, airplanes or whatever. I mean, I wouldn't necessarily use an omnidirectional mic just because it's the least susceptible to wind noise. But if that's something you're looking for, that is a quality that you're going to get out of an omnidirectional microphone. So good question.
Awesome. All right. We want to thank you so much for joining us today. We hope you learned a little something. I know I always do. And we'll hope to see you on the next one. Have a great day, everybody, and take care.